Alright, so Monday, and this is NET-200. Talk a little more about the physical layer. Students are working on their cables. Okay, I know some have them done. And then we talked about Ethernet topics. MAC addressing and IP addressing. We don't do a lot with the IP addressing yet, but we need to talk about it in relationship to MAC address. And we talk about Ethernet and the frame and so forth. This is week 6 and day 10 of the introduction to networks. Now, talk a little bit more here about the OSI model. These are all similar in terms of application, present the data, set up a session. And then we talked about transport. We've already talked a little bit about that. We have specifics on it later on. Network layer, IP addressing, and then in this particular week we're talking a lot about the data link and Ethernet in particular. Link control. Logical link control connects us into the layer above. The MAC, media access control, connects us into the physical layer. You know, the media, some kind of a wired solution, wireless, or fiber. So then we talked about, as we move down, we get this data, and then we encapsulate it, we break it into parts, give it port numbers, then we take that and make a packet with IP addresses, then take that and encapsulate that into a frame. And we should have an idea of what those frames look like, you know, what's in the frame. Okay? Of course, right now we're talking about an Ethernet frame. We looked at this scenario here, in which we have a router that I have configured connected into the NIACC network, and then the NIACC network is connected into the internet. We connected a switch to that router, and then all of the students connected to the switch in order for us to talk about Ethernet today. So everybody added a workstation to the switch. I have configured DHCP on the router, so then that distributes the IP addresses to everybody. And then the network that we have configured the students all got an address on this network. We talked about right here in the router was the default gateway, and we gave the switch a VLAN 1 address for management purposes. Alright, and then we also looked at the students did an ARP, and then they could see from the ARP the connection between an IP address and the physical address, the MAC address, and they could see those connections between the two. And then we talked about the students were able to find the MAC address for the router because they could look at their default gateway they could take a look at that default gateway, and from that they could look at their ARP table, and then they could come up with the MAC address for that router. Alright, then we talked about base 10, we have 10 digits, 10 to the 0, 10 to the first, 10 to the second, so we can go an infinitely big number, 1 over 10 to the first, 1 over 10 to the second. We can go to an infinitely small number. We just keep adding places. And anything to the 0 is 1, 10 to the first is 10, 10 to the second is 100. So if we had 1 digit here, 1 digit here, and 1 digit here, that's 110. Let me just do another example, another color. So if we had a 8, 2, and a 5, we have 8 groups of 100, 2 groups of 10, and 5 groups of 1, 825. Similar thing occurs in binary. Base 2, binary, 2 digits, and we use 0 and 1. So we actually do the same thing. 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32, 2 to the sixth is 64, 2 to the seventh is 128. So if we were to look at this, we have 0 128s. Here we have 1 64, 0 0 0 0 groups, 0 groups. And we have 1 group of 1. So if you add that up, 164 and 1, that's how we get 65 base 10. Alright? So it's binary. So if I had something like this, let me put another one in there, another color. If I had a 0 0 1 1 0 0 1 0, I'd have 1 group of 32, 1 group of 16, 1 group of 2, and then that would be it. 10. So that would be base 10, that would be 40. Now we can do this in reverse, and let's see what it looks like here. Here we took, we had the number 192, and we converted that to binary, ones and zeros. You know, we had 192.168.1.0 for the addressing in our work that we were just doing. Well, we're able to take this and convert it to binary. This one to this one, this one to this one, this one to this one, and this one to this one. Those are called octets because there's 8. Okay? So, here's what we did, and you can kind of follow along here. 192, so we can take one group here of 128 out of 192, and that's where this one came from right here, because we have one group from here. And then we subtract that and we get 64. Now we can one group from the 64, I should really mark it up here, one group from the 64, and that's this one right here. Take 64, we subtract those and we get 0. So this is this number here. That's in binary is the same as this number here in decimal. So we did the same thing for for 168, we got this number. We took, let me see if I can clarify that. Let's do that in blue. Blue. So we took, out of 168, we took one group of 128. So we can take 128 away from it. Get 0. Then we end up with 40. So we took a 128. You can't take a 64 out of 40, but you can take a 32 out of 40. And that's where this one came from. 32 from 40, and we end up with 8 left over. And that's where this one came from. One group of 8 here. Yeah, we're going to practice. The 2 years are over. So now you can kind of see the process. Okay, so this is the process we use to get this here, and this one is the process we use to get this here. Now this one's just 1. We got the 1 in there, and then this one's all zeros. All zeros. That's it.